Hello and welcome to this Alva instructional video. My name is Lars-Endre Mæland and I'm a principal mechanical engineer here at Alva. In this video we'll give you an overview of how you can integrate Alva's SlimTorq motor in your application. If you have questions about topics in this video or want more information about our products, please check out our product catalog or visit us at alvaindustries.com. The fundamental difference between a framed and frameless electric motor is that for a frameless motor, the stator and rotor is applied as two different parts. The joining of these two parts happen in the final product assembly, and it's up to the designer of that product to make sure that they are implemented in a good way. Retention and alignment must be considered so that the stator and rotor is held firmly in place and also aligned so that they don't come into contact with each other. Both stator and rotor axes must be well aligned to the shaft's rotational axis to maintain clearance. We will now discuss three different concepts for how the stator and rotor can be integrated. These are axial clamping, adhesion with a thin bond line, and adhesion with a thick bond line. Each of these concepts have their own associated drawbacks and benefits, and will to some degree dictate how alignment is achieved. By axial clamping, we mean that the stator or rotor is held in place by friction by being compressed between two parts in the axial direction. The radial alignment is achieved by having a snug fit between the OD of the stator and the stator housing, or the ID of the rotor and the shaft. The axial alignment is controlled by the position of the clamping parts. For optimal terminal performance, a thermal grease can be added between the parts, particularly between the stator and the stator housing. It is important to note that the axial clamping force should only be applied to the outer aluminum ring of the stator or the inner aluminum ring for the rotor, not the magnets or the stator winding. The clamping force should also be evenly distributed around the circumference and properly scaled to make sure the contact pressure doesn't get too high. Please refer to our mechanical integration guide for more information. Axial clamping can be beneficial in the assembly process since it does not require the use of adhesives and the associated curing cycles. In a thin bondline solution, there's a snug fit between the OD of the stator and the ID of the housing, or the ID of the rotor and the shaft. Assembly fits should be close clearance or transition fit. This will ensure a good radial alignment. Retention is achieved by use of a retaining compound such as Loctite 638 or 648. A retaining compound is basically an adhesive specially adapted for bonding close-fitting cylindrical parts. The adhesive will require some cure time, but since the assembly is self-aligning, you can generally avoid the need for clamping or fixtures. Axial alignment of the stator or rotor should be achieved by a hard stop feature in the stator housing or in the rotor shaft. Such features should only contact the end face of the outer aluminum ring of the stator or the inner aluminum ring of the rotor. Also, if any substantial force is required during the assembly process, that should only be applied to the same faces. As always, when working with adhesives, proper surface preparation is critical. The OD of the stator is analyzed with a special process to enhance adhesion. In most cases, a thorough clean with isopropyl alcohol will be enough. For bare aluminium surfaces, like the ID of the rotor, we recommend cleaning with isopropyl alcohol both before and after roughing the surface with 80 grit sandpaper. The appropriate surface preparation depends on the details of the application as well as the product being used. Please consult the technical data sheet of the adhesive you're using to find the correct procedures. And as always, consult the safety data sheet for the correct safety precautions. For the best thermal performance, the stator-to-stator housing gap should be filled with adhesive. Any adhesive will have a higher thermal conductivity compared to air, so minimizing the amount of air voids will dramatically improve thermal performance. In a thick bondline solution, the gap between stator and stator housing, or rotor and shaft, is relatively large, on the order of tens of millimeters. This allows for a wider selection of adhesives to be used, for example adhesives with higher thermal conductivity. Radial alignment can be ensured in one of two ways, either by keeping an alignment fit on part of the interfacing surfaces, or by using a jig to hold the part in the correct place while the adhesive cures. The second option can be a good choice if for some reason it's unfeasible to achieve good alignment by assembly tolerances alone. For example, if the stator housing is made by a less accurate production method. By having a tool or jig that locates the part, some of the misalignment can be corrected for in the glue line. This can be done for both stator and rotor, However, we generally do recommend that the rotor be aligned by machined surfaces on the shaft, as this is generally more repeatable and accurate. When assembling the parts, some adhesive squeeze out is to be expected. This should be accounted for in the design so that it's possible to clean off any excess and that it doesn't get anywhere where it might cause trouble, such as into a bearing. Something to note about the thermal performance of the bonded interface is that the thermal resistance is given by both the thermal conductivity of the adhesive as well as the thickness of the bond line. This means that a really thin bond line with normal adhesive might have similar thermal resistance to a thick bond line with highly conductive adhesive. In any case, the worst situation for thermal performance is if there is air-filled voids in the bond gap. So good filling is important no matter the choice of adhesive. Finally, a brief note on interference fits. The use of an interference fit to both align and retain the stator or rotor is possible. However, many factors such as operating temperature must be taken into account to avoid overstressing and damaging the stator or rotor. If you're looking to integrate the Alva frameless motor using interference fit, please reach out to us and we will help you find the correct solution. I hope that you found this video both informative and inspirational. On our website, alvaindustries.com, you will find our product selector, which is a great tool for finding the correct SlimTorq motor for your application. If you have any questions about the topics in this video, please do not hesitate to reach out to us. So, in which application will you use Alva SlimTorq motors? Let us know in the comment section below.